Was there anything that was just so surprising to you, just changes within the astronaut from Earth to space that you didn't expect, that perhaps that their needs were much greater or, again, different? For example, satiation, being able to eat to capacity, that's probably different in space flight than it is when you're eating on a gravity-based planet.
Indeed. And a couple things there. One, we did some studies a ways back documenting that energy expenditure is the same during flight as it is on Earth. Or if it's not the same, it's higher, depending how much they exercise. So the immediate assumption is that you go into space flight, you're not walking around to the same, to the same degree. You're not working to the same degree, so you probably need fewer calories. And the reality was that's not the case. That for reasons we don't fully understand, your body's burning the same number of calories as it did on Earth. And to that end, you need to consume the same number of calories to maintain body mass. And historically, we've seen a lot of crews lose weight during flight. And when we meet with astronauts before flight, I always tell them that if I can only tell you one thing, it's that you need to eat enough, you need to get enough calories, and you need to maintain your weight. That if you're losing weight during spaceflight, you're losing more bone than you need to, you're losing more muscle than you need to, your cardiovascular system doesn't like it, your oxidative stress goes up, and this is not the place to lose weight. And we've seen a lot of crew members that we said, look, you're not eating enough, you need to eat more. And they said, look, I'm eating till I'm full, I'm fine. And we said, look, if you look at your body mass, it's going down. So there's something not right. I don't have data to back it up, but what I think is happening is that satiety signals are different during flight, and that food settles in your stomach differently, and that in essence, your stomach tells your brain that you're full before you are. And we encourage crews all the time that you need to, we have an iPad app up there that they're using to track their intake, and the crews have really responded well to that. And they enter the food as they're eating it. So at lunchtime, they can see where they are relative to their energy requirements, and they know how much more they need to eat at dinner to round out that day. And I tell them all the time, either you need to push more food in at meals, you need to snack more. It doesn't matter, but job one is to get those calories in.
Do you find that the microbiome of the crews resemble each other if it's something that you look at?
There have been a few microbiome studies during spaceflight. And at this point, I don't think we know enough about microbiome in terms of acting on it, really on Earth or in flight. We know the microbiome is very important. We know that your diet will affect it, but we don't really know yet what to tell you to eat to make your microbiome do something that will turn around and help your overall health. We know things like more fruits and vegetables, more, a better diet, more omega-3 fatty acids will produce a more beneficial microbiome. We haven't been able to do a study on orbit that could prove that, although we have one that is ongoing where we're testing providing better foods to see health outcomes, and microbiome is one of those. But again, we don't really have that data yet. Nonetheless, we know that the microbiome is important. We know that there's reason to be concerned about that during flight, but being able to act on that in a concrete way, we haven't been able to do that yet.
Have you looked at omega-3 fatty acids in the brain and protection during flight?
We haven't looked in relation to the brain, but we have looked at bone health. And what we showed is that crews that ate more fish lost less bone. And we actually did ground-based studies where we showed the same thing, that more omega-3 fatty acids were protective of bone in bed rest subjects. And we did cell culture studies where we took cells and put them into a microgravity type environment. And if you added omega-3 fatty acids, they would be less osteoclast inducing. So again, they would suppress the bone breakdown mechanisms in those cells.
We're definitely seeing fatty acid effects on skeletal muscle from preventing sarcopenia, changes in, or at least mitigating atrophy. And, that is very important, of course, as individuals age. Do you feel that individuals age exponentially during spaceflight?
I don't know about exponentially. I know there have been a lot of people that have made the argument that when you look at the changes that we're seeing in astronauts, that they look a lot like aging. Mm. So muscle loss, bone loss, cardiovascular deterioration. So I suppose you can make the argument that spaceflight appears to be accelerated aging. Sure. I look at it another way, as a lot of our research has been done looking at diet and bone health and bone loss during spaceflight. And again, those changes will mimic some of the things that we see in people on Earth. And what to me is fascinating is that we can study astronauts that are up there for about 6 months and looking at either dietary changes or exercise changes, we can see things in generally very healthy people put in a very strange environment. And we see changes in bone in 6 months that you would see on the order of about 5 years on Earth. So I think of it as it's almost like time-lapse photography where you see things happening much faster. And the work that we're doing in spaceflight, even though we're trying to prevent bone loss in a relatively small population, the work that we do helps to inform the scientists on Earth that are trying to study osteoporosis in a much larger group of people. So again, I wouldn't go as far as to say we're going to cure osteoporosis, but as with every other bone researcher out there, we're all contributing pieces to the science that when you step back from all those pieces of research allows you to see the picture of bone health and bone metabolism and effectors on that can help to ultimately mitigate disease.